Hi, everyone. I'm Andrew Mahan. I'm a mass spec group leader in the cell engineering and early development group at Janssen. And thank you, Jane, for the opportunity to speak, and also very much thank you to Waters for this opportunity. And today I'll be presenting on the evaluation of next generation Waters QTOF MS for biotherapeutic characterization. I will start a bit with my role at Janssen and what I do, where I work in the biopharmaceutical industry, what role our group plays. And then I'll step through a user perspective of the new features and improvements on the Xevo G3 QTOF. We'll also evaluate common mass spec performance attributes such as mass accuracy, resolution, sensitivity. Really, we're excited to test out this new mass spec. And then using our molecules, we did an early evaluation of this instrument, mainly for biopharmaceutical characterization, some of the more platform assays, as well as some of the emerging areas. I wanted to challenge this new instrument to show improvements in peptide quantitation and dynamic range, and also at the same time assess operation of this instrument within another new software platform, Waters Connect. It's a ecosystem, so to speak, of software to integrate everything. And finally, I can show a few of the new apps that we explored, such as Intact Mass. So my group in Janssen is titled Cell Engineering and Early Development. And what we do is we bridge discovery and the development organizations. So we integrate with discovery on the left of this diagram shown here, and then as we develop cell lines, then we integrate also with full development organizations. So we play a critical role in that we're taking large numbers of candidates of biotherapeutics, and we're getting down to that part, you could say, in the funnel where we have 1 to 4 lead molecules, and then the organization decides that we're going to invest the resources to develop a manufacturing cell line in a stable cell. So that's where the mass spec characterization also steps up at the same time, because it's very critical for us to characterize these molecules while there's time to make some changes. So essentially, we're combining the cell and development sciences group with early development for this process. Today's pipelines, as shown on the left, are becoming increasingly complex and more diverse as we're doing everything we can to meet the needs of patients and address current diseases, the challenges. And so that just means some of the traditional MABs are coming in a bit more domains and such as with multi-specifics, multi-chain molecules. Shown on the very bottom is another version. We also have different modalities. I'll show later in this talk oligonucleotides, ADCs, and alternative scaffolds. Okay, so shown on this slide is the cell line development process. This is approximately a 4 to 5 month process where we start with transfection pools and go into single cell cloning, eventually bioreactors, and the model has been where analytical in the past has been a final step, and we've evolved this support model where really mass spec is playing a role at the very early at the transfection pool stage, and at each stage. So instead of serving as a really a checkpoint at the end, we're really a tool to create better cell lines with higher product quality. So the demands for mass spec have increased, where as we're more of a parallel process. So we don't want to be a bottleneck, but rather enable this entire process to make better manufacturing cell lines and deliver comprehensive characterization of the final lead cell lines. At the same time, we're shortening timelines and increasing the number of molecules and protein platforms that come through. So the focus of this presentation, as I show on the right on this table, is these bold, is to look at some of these more what we call platform assays, such as intact mass to confirm molecule ID, purity. We look at glycosylation of these variety of modalities by reduced intact mass or other MS techniques, glycations, another attribute that we monitor. That's the addition of glucose to lysines that can happen in bioreactors, culturing. And then a lot of work goes into peptide mapping, looking at sequence variants, clipping, and other PTMs. So to do that, we rely a lot on, of course, our instrumentation. And the instrument that I referred to earlier, this next generation, is this Xevo QTOF G3, as shown here on the right. It is a very streamlined looking instrument with the Premier UPLC inlet there on the left. A couple of changes I noticed, or attributes that I really liked, is the ability to operate and tune and assess the instrument, as we're not always in the lab, so we're able to operate remotely. As we've been through 2020, we know how to keep businesses going forward when we may not be able to run in and put on a syringe and tune the instrument. So shown here is a schematic of the Waters Xevo G3 QTOF. If you're like me, I have this memorized. I know every bit and part. So when I heard about the next version of Xevo, I was very excited to step in and see what changes have been made. Because for me, in the biopharma industry, these changes translate to improvements to make my life easier, to be able to do more. And what I've always mentioned is that this is a cycle where, as users, we feedback to the mass spec vendors that this is what we need. It's a continual process, and then instruments evolve, which allow us to do more. And so it's that continuous partnership between us that I think push science with, we can all say, instruments such as this allow us to do more with the molecules that we're developing. Let me start with some of the, just touching on a few of the improvements on a bit of a higher level. The StepWave, which has been the front end in Waters Instruments, has been redesigned for improved ion transmission, and mainly for molecules that are thermally labile or fragile. So there's less energy imparted in this step of the instrument, resulting in improved sensitivity up to 10x for certain molecules, and even for peptide maps, we show some improvements. There's been sometimes it's the things we don't think about, like the dry vac pump. That's quieter, it's less heat, and it's less maintenance. All those three things are wins in my book. Less times I got to go in there and fix anything. I wanted to mention the dynamic range, the DRE lens. These instruments are becoming more smart, so there's this intelligent control of this lens to really one can push the limits of the mass spec as far as dynamic range, and the instrument's smart enough to keep the beam on scale through some sophisticated programming there. There's also been a redesign of the ion optics leading up to the TOFs to keep the entrance lens from getting contaminated, and that's another increase in uptime. And lastly, improvements in the digitizer, which increases the in-spectrum dynamic range of the instrument significantly. We focused on the biotherapeutics, and so what we'll show is extended M/Z range, which is helpful as we're doing more denatured analysis to look at MAB aggregation and other protein interactions. We will also touch on the integrated workflows that have been introduced in Waters Connect, where we can go from acquisition to reporting. I don't mention it as much in this presentation, but it also comes with a tremendous improvement in UPLC, and that's the Premier, which enables LCMS analysis without bias for accurate and robust results. And it's definitely a compliant-ready network deployment on Waters Connect. So Waters Connect is at the center of this integrated network, and what I'm showing on this slide is really where the Xevo fits in to this ecosystem. Is one could consider this as a continuum of characterization would be performed on this mid-tier instrument. The Xevo is the analytical workhorse in the lab, so it's one of those instruments that's just always running around the clock and doing deep characterization. As we learn more about the molecule, then we can categorize the attributes, the critical quality attributes, and then as some of the assays are developed, we can then go into more attribute analysis or more routine, or even into the QC labs. So this continuum can all exist on the same network server. In our existing setup, we actually have our server in AWS cloud, and so we're actually writing the data directly to the cloud, and then the users in our group with clients are able to all access data, control the instruments, and work in a compliant environment. So we're going to go dive into some of the data from our molecules. So really we wanted to test out the instrument. And one of the most common, and I argue one of the most useful assays with a small amount of material, but just provides back so much information, is the intact mass assay. And this app was really designed to screen. One could have a full plate of 96 different MABs, and the user would, in this workflow, a couple of entry were enter the expected mass for each of the therapeutics. Not only do we get mass confirmation, we also get purity determination. Those are the two key attributes that I think is so valuable about intact mass, is that number one, we make sure we made the correct molecule, and two, what is the purity of that molecule. And we can see from a high level is how does that all of our samples look. This is another point I wanted to mention that I experienced in using this intact mass app. It was that it has automated peak picking, so we don't have to go through deconvolution settings. Especially what most impressed me is this intelligent automated spectral deconvolution. So really our input is just that we have a protein, and the software will do all the work. We don't have to set mass ranges or any of the settings that we typically would have to do, like in Maxent. So it's very intelligent and does all the work. And as we can see, really clean, crisp data from the instrument. What I look for is the resolution that we see on the TOF instrument to be able to clearly resolve the glycoforms and any other proteoforms. This Xevo instrument did an exceptional job in resolving this antibody, the features of it. We also looked at other more common platform. We typically will step through also a reduced mass, and what that does is it provides us a look to make sure not only is the intact the correct mass, but when we look at the light chains and the heavy chains, we also can look closer at the modifications, whether we deglycosylate the MAB or keep it native. We get a little bit of a closer look, and the spectra from this instrument were just tremendously crisp and clean, and the viewing the data in this app made it all the more of a nice experience. This is just shown another one of our internal molecules, and looking at the data from more of a light chain, heavy chain view, we can look. We typically will monitor glycoform from the heavy chain, so it's a bit easier to assess the levels of G0F, etc., when it's individual light chain, and also more clearly we can see undesired modifications to the protein and can use it as a diagnostic tool. On this slide, I show the Unify Intact workflow, and this is a companion, or can think of it as a different way when we need more information, so we can work through what the workflows that we were all accustomed to. That is still available in Waters Connect. And we confirm the mass, and also we can really determine the relative abundance of different modifications. And then I show here really that high quality data coming from the Xevo G3 instrument, just really clean. And what I noticed in this spectrum, it was the stability of the signal, and the range of detection has improved quite a bit compared to other QTOFs. We also tested out this instrument in, I would say, a growing area in biopharma is that we also need to assess these molecules in their native state, mainly for the reason is because there's non-covalent complexes that can happen, and we want to know how are these antibodies aggregating, are they forming trimers or mixed. We look at multi-specifics quite a bit, so the question is, are we forming aggregates, mixed aggregates, or so we really needed mass spec to determine the identity. And also where the Xevo G3 has improved the mass range up to 16,000. And this is an improvement. So I show here this really high quality native SCCMS that was collected on the G3. And this charge envelope of the MAB is about 5,000 to 6,000, deconvolutes cleanly to within 1 Dalton of the expected mass. As we look a little bit closer, we're also able to see the dimer of the MAB, and this really shows the ability of the G3. Even though this particular sample didn't have a lot of dimer, we're able to dig that out of and less than the 1% part of the spectrum, and we see a protein envelope from 7 to 9K. So right away, I'm seeing improvements in that extended mass range on this instrument on a pretty straightforward molecule. Peptide map is another very, I would say, a lot of our workflows and effort goes into mapping the biotherapeutics, confirming sequence. Most of the mod quantitation is done from a peptide level. It provides us the localization, sequence variants, etc. We need to look at the molecule from a peptide level. And showing here on this slide is this tremendous reproducibility. You might not know, but there's three overlaid injections. This is a TIC, and so that's definitely speaks to the UPLC, but also to the stability of the mass spec instrument to be able to do that. And the sequence coverage in this is the MSE workflow, high sequence coverage and very good high mass accuracy. The MS spectra were also high quality and accurate mass, which provides us the opportunity to not only detect modifications, but to localize that modification to the specific residue. So here in this lower spectrum, we do see a deamidation on the Y3 ion, and that lets us know that this asparagine was deamidated to an aspartic acid. So the MSMS data is really spectacular on the G3 instrument. And just looking at the resolution, I selected a really probably common peptide that if any of us that have done a lot of peptide map, we see this usually towards the later eluting peaks. This is because it doesn't have a lot of Ks or Rs, it ends up being a pretty large peptide if you're using trypsin. So for me, it's a little bit of a reality check. I make sure that I detect that peak, and so this is a pretty large peptide at 6.7 kilodalton, and the resolution of this instrument is fully able to resolve this +5 with plenty of space in between these peaks. So that's really exceptional resolution and performance. I had mentioned earlier about this redesigned StepWave. A couple of goals in that was, as always, to improve sensitivity, ion transmission efficiency. However, one of the more noticeable effects is the lower in-source fragmentation due to the energetics that Waters has really put a lot of thought into how to improve that. It's also observed in particular small molecules that are fragile, and Martin will go into detail about that. But what we can look for on the peptide level is, for example, glycans are an example of a modification that typically when we perform mass spec on these, the first thing that happens is that they do sometimes fragment in the source, and those can be seen by pieces of the sugar, what we call oxonium ions. And so, in comparing to other vendors, this is typically at around 10% or more of these oxonium ions, and we observed an improvement on this instrument down to as low as 2% due to the improvements in this StepWave. Dynamic range, the QTOFs are as I mentioned, the workhorse, but they're also being put to the task for quantitative experiments as well. And the Waters has stepped up in this area. So, for example, shown here is a full scan data. This is just as this would be obtained from a typical peptide map. And we're able to see 4 orders of linear dynamic range from several peptides that were spiked into NIST. So it depends on the experiment that we're performing. If it, for example, for a TOF MRM, due to the improvements, that linear dynamic range steps up to 5 orders of dynamic range, which is really exceptional. So I switch a bit to talk about how the Xevo really fits into this ecosystem. We also have on the same network is Waters BioAccord instruments, and so not only can we go from characterization to targeted or attribute analysis, but we also provides us the opportunity to, in a very busy biopharma lab, to actually dedicate some instruments for particular assays. And so shown here is actually 2 presentations, and the one is a spent media analysis. Is that we've characterized the biotherapeutics, the proteins, the peptides, but it's also important for us to look at the metabolites in the bioreactor, and this ends up being a bit of a metabolomic study. And Waters Unify has, we've been in collaboration on this, but we're using the small molecule tools to really go through and perform very detailed analysis of over 200 cell culture metabolites. It's a pretty straightforward prep, and the method, all of the software is self-contained. There's a compound library, so we can determine the identity of unknowns and keep building that library so that compound list grows. And what I want to show is that we look quite a bit at these trend plots. And what we're interested in here is how our metabolite or an amino acid, how that is changing if we sample the bioreactor at different days. And for example, if we ever misincorporate an amino acid, we can determine if we're low or depleted in any particular metabolite. We also try to associate the levels of these metabolites with product quality, maybe something negative attribute, and sometimes the answers are in this data. So it's also important to look at this. The entire workflow from the instrument to Unify, there's this multivariate data analysis and automated reporting all in one. So we've applied this to many projects at Janssen, both typical cell line development and also exploratory science. Showing another application on the BioAccord within this network of mass specs is release glycans. And here's a COVID spike protein where we're looking at our role was to create a stable cell line coming from transient, and really can see quite a difference in the release glycan profile, and the BioAccord played a key role in that. I also want to comment on the ability of external applications here. We also collaborate with Protein Metrics, so we use this external application to extract data from Unify. We can also export raw data into MassLinks, which allows us to go into many other software applications and also import data. So there's a lot of flexibility in Unify, even though we're within a database. It's both positive, the ability to keep everything within a database, but also the ability to move data out and also work with other applications. Depending on the question you're asking, really determines what app you'll want to use, or what type of instrument and in what mode. There's differences in the levels of mass specs with dynamic range and sensitivity. The Xevo allows DDA type workflows, targeted MS, whereas the BioAccord, we could transfer the method to there and monitor specific PQAs. To summarize some of this very positive evaluation that I have of the G3, it really exhibited excellent performance for the analysis of intact MABs, which this has been a workhorse in our lab, and I was excited to see the improvements. It showed superb resolution of the glycoforms and other proteoforms. We are able to test out the extended mass range, which is ideal for native applications. The peptide map had really great mass accuracy and resolution, and the quantitation, 4 orders of dynamic range in full scan mode, was really great to see. The technical advances, which Martin will go into, is already on top of a solid, really instrument platform. So this mid-tier instrument is the analytical workhorse in really any biopharma lab. And then this all fits into this Waters Connect, which is a plus for me in evaluating where this instrument fits in my lab, because I can just park it into its spot and it fits to already. I have the software ready to go, and the team has client software, so we can hit the ground running. So it provides that framework to network several mass specs. And from my perspective as a group leader, it really promotes team collaboration, data sharing, and review, so that there's not data all across the lab. It's within one place, and we're allowed to build libraries, methods, and data all in one location. And I was really impressed to see these new apps. But I wanted to really highlight the stars, and that's not me. It's Owen Cornwell for your help in collecting the data, and Samantha Ippoliti for helping to really process and teach me some of the new apps, and also Elsa on my team for really to help making this presentation look great. So this was a really strong scientific team at Waters that I was able to be a part of, and together I think we're able to evaluate this instrument and really push it. So I did want to thank you for this collaboration, and for this performance of the Xevo G3 for biotherapeutics. Thank you for listening.